First of all, Christian, thank you very much for setting up this presentation series. I think it's very important. I also want to thank everybody here in attendance. Thank you for taking time out of your schedules today. I know how busy you all are, and I hope that I can provide some information here for you. Leading off from Pietro made some very good points, and I'll definitely touch on some of those aspects as well in my presentation. This is let me go and give you a little bit of background of myself first. My name is Bill Nader. I have been, majority of my career has been in the activated carbon industry working for Norit. I was a senior applications engineer and was responsible for all water and gas air applications. So as a senior applications engineer, I took care of all technical inquiries, product development, testing and market development. And it was a natural extension to move from activated carbon into biochar. Became interested in biochar, and interestingly enough, activated carbon companies have been making biochar for quite a number of years, wood-based products primarily, but I'll touch on that here in the presentation. But I see biochar having a great future because biochar allows itself to be modified in ways that activated carbon would not yield the same type of properties. Biochar, because there are so many different types of raw materials, there are so many different products that you can make from it, and you can tell from Pietro's presentation, you're limited only by your imagination. I'm part of Lee Enterprises Consulting Group. I'm an affiliate of theirs. This is a group that has 50 experts now in all areas of the bioeconomy. So we are positioned as a one-stop shop for all consulting needs, from anything from financial to actual regulatory to manufacture. So it is, like I said, I'm affiliated with this group because they are heavily into the biochar area. My activated carbon and biochar experience, I hope, lends itself well to the group. Now, what are the differences primarily between biochar and activated carbon? As I've been developing contacts throughout the biochar industry, one thing keeps coming up is it possible that to replace activated carbon with a biochar product? And the answer is yes, under certain circumstances. And we're going to talk about those differences between biochar and activated carbon, because biochar is well established in a number of industries, but primarily in the United States, it's for soil addition, soil amendments. Activated carbon is more limited, but has much larger volumes. And it also commands a higher price. So biochar manufacturers are very interested in moving their products into higher profitability, higher margin markets. So what I'll do in this presentation, we're going to take a 20,000-foot view. We're going to review the similarities and differences, as it says, between biochar and activated carbon. We'll talk a little bit about making an enhanced biochar. Like I said, I'm not going to cross more to that, just gives us, like I said, a 20,000-foot view. And then finally, suggestions for biochar manufacturers, because a number of my clients are biochar manufacturers who want to push their biochar into the next phase or the next level, get into the activated carbon market as it was to, like I said, realize that higher profit potential. But fundamentally, the stories of biochar and activated carbon, they're actually quite similar. As I mentioned, the activated carbon manufacturers have been making a biochar for years. They make a chemically activated wood is primarily the next highest volume product made by activated carbon manufacturers. I know that there are coconut shell manufacturers as well, but I'm dealing mainly from the U.S. domestic markets. And the difference basically is that most activated carbon sold in the United States and around the world are coal-based, either bituminous or lignite coal. These are just different ages of coal, geologically speaking, and are activated typically at 900 to 1,000 degrees centigrade. The chemical activation of wood, it uses phosphoric acid to break down the cellulose structure and is activated at about half the temperature, about 500 degrees C. Now, what they all do is they all produce porosity, and I'm sure that many of us are familiar with porosity, so I won't use a lot of time in our presentation on that. But just to remind everyone that the porosity has been classified by the activated carbon industry as falling into three categories: macropores, mesopores, and micropores. Macropores are very, very large pores that are also referred to as transport pores because no absorption really occurs in them. Then you have the mesopores, which can handle large organics, and then the micropores, which can handle the smaller organics and also are particularly good for vapor phase applications. So what they share in common is they're both carbon-based and they're both porous materials. They're also purification media in liquid and gas. When I say liquid gas, I'm talking about any medium that you can imagine, or the active agent in a separation process, because sometimes you will add an activated product because you want to capture something of value that's in a solution. Now, the biochar raw material, as I mentioned, is predominantly cellulose biomass, where activated carbon is primarily bituminous and lignite. But the activated carbon manufacturers have produced a biochar, if you will, a wood-based carbon for many years. So they have been in the biochar industry, whether they acknowledged or realized that they have been making biochar. Now, the fundamental differences between biochar and activated carbon is that typically the iodine number for biochar is going to be 500 to 600, and activated carbon 500 to 1,000. Now, iodine number is a measure of the surface area of the pores. And this was a technique that was developed by the activated carbon industry to give them a manufacturing test, something that could be done on site at the kilns quickly. So there is a relationship between iodine number and surface area, BET surface area. But when you see these numbers, 500 to 600, 500 to 1,000, that refers to square meters per gram. So when you see the, it's essentially equivalent to surface area. Now, biochar pore sizes are primarily larger, macro and mesoporous. However, if you do a chemical activation, you can get more microporosity. And with enough control, you can produce a very, very highly active carbon, far more active than a coal-based carbon. The activated carbon, of course, can be macro, meso, and microporous, depending on the raw material. Younger coals, if you will, geologically younger coals, such as lignite, can be made into, will make typically macro and mesopores, larger pores, whereas a bituminous will make typically smaller pores. Now, here is one of the fundamental differences between biochar and activated carbon, and this is one of the things that they create some barriers or hurdles that need to be engineered away, is the density of, you can see, is a quarter of what activated carbon is. And that low density has advantages economically if you're doing volumetric fills, but it does make it just a little bit more difficult to handle. So there is some cost associated with that. Now, with regard to the ash, biochar is very favorable in this regard because you can typically have a very low ash, whereas at activated carbon, it could be very high. You can see as high as 25%. But then when you talk about, and I included coconut under the activated carbon because coconut is widely used as an acceptable activated carbon for gas and water treatment. But below there, you see how the pores are classified. Micropores being less than 2 nanometers, mesopores 2 to 50, and macropores being above 50 nanometers. The forms of biochar and activated carbon, typically activated carbon is going to be available as a powder, a granular, or extruded. And we're going to talk now about one of the other, not a disadvantage, but something that needs to be, we need to figure out a workaround. Of course, we can make a biochar that's powdered. And because we have experts already listening here to this, into this seminar, and thank you very much for being here, that can make extruded pellets. But typically a biochar will not make a granular. And that closes off a number of markets to biochar, but does not prevent them from being used in areas where granulars would be used. So extruding or pelletizing a biochar can overcome that two not deficiencies. I don't like to use the word division because I love biochar, but two aspects that would make it more acceptable by activated carbon manufacturers. And that is, by extrusion, you can overcome the density and the hardness issues. powdered carbon can be sold widely and is still used very widely, and that should be no problem for a biochar. But granular, probably it'll be powdered or extruded. Now, one of the things that I have, as I've learned more, is that biochar can be modified in, again, almost an unlimited number of ways. So it becomes a much, much more versatile raw material than coal. And for instance, some of the applications that I've seen are slow release fertilizer. Basically, what you do is you'll have turf manufacturers, people that produce fertilizers and soil amendments will sometimes load up a biochar, then put it into the soil for slow release. So basically a long-term fertilizer. Odor control, hydrogen sulfide. This is an interesting application because typically with gas phase application, a hydrogen sulfide and other odor control applications such as asphalt plants, sour gas from oil and gas companies typically require a carbon that is very microporous for most gas phase application. But for odor control, it is a catalytic reaction with the carbon. And so biochar can be modified very effectively to handle a gas phase application, which is atypical, but in this particular application, it works very well. And an extruded pellet, 3 to 4 millimeter in diameter, is particularly well suited to this type of application. Some years ago, I had a client that took a biochar, a wood-based biochar, and sprayed various additives on it, and it made a very, very effective odor control product. I haven't seen much of that since then, but it is very much of a strong and growing market for odor control. Groundwater, again, and I'm going to discuss some capabilities of biochar in just a moment, but it has very good metals removal. It has good potential for removal of radionuclides. It can be used in watershed protection and potable water treatment. I have seen articles where biochar was put into fabric bags and literally floated in a lake or a pond to clean it, because it would do a very passive absorption, but it would clean the water. So it makes the water that comes into water treatment plants that much easier to treat. And the biochar is a very economical way of achieving that purity. And then finally, in aquariums and aquaculture is an application where the low density makes it very, very appealing to the manufacturers of the filters used in fish tanks and aquariums and larger aquariums as well, because it requires less pounds to fill a given volume. And of course, that is appealing both to the original equipment manufacturer as well as the end user. And this is by no means, this is just a small sampling of some of the potential for biochar in the future. So what we've discussed here is that we have good porosity. So when you create a biochar, you have wide open pores. You have usually a variety of pores. Different conditions produce different biochar material, but if your porosity matches the contaminant you're trying to remove, you're going to get very fast absorption. Typically, biochars are higher purity and lower ash than activated carbon. It has a lower density, so as we talked about earlier, lower cost on volumetric basis, so less pounds, less cost to fill a given volume. One of the things that's really come up a lot lately is metal absorption being superior in certain conditions. And you look at the last point, high cation exchange capacity. It's almost like biochar can work as an ion exchange medium. So it has potential beyond coal-based activated carbon. Because it's organic, it's well suited for biological systems, and it has also been demonstrated to have high chemical oxygen demand reduction. And chemical oxygen demand is a non-specific group of chemicals that contribute to what is known as the overall toxicity of a wastewater. So you can have toxicity reduction with the biochar. So wastewater also becomes a very good market. And because it's renewable and sustainable raw material, the green aspect of the sustainable aspect of it, it closes the loop, if you will, from a living product to something that has gone full circle. And this is, again, one of the things why biochar has such a high appeal to myself and so many others. Now, if you're a biochar producer that wants to really make a serious effort to promote your product into an activated carbon application, there are some things that need to be established in order for you to be, in order for customers to really believe that you have a product and can be their supplier. Is you have to be in continuous production. And I know that in biochar, a lot of biochar manufacturing are smaller operations. So continuous production is absolutely critical. And in order to have continuous production, you've got to have a reliable raw material and consistent quality. And then you've got to start doing properties testing like those you would do for activated carbon. This helps to show the end user that you are a strong company delivering a good, consistent product that meets the specifications that they need. So going into it, you need to, obviously the customer's interest is already there because it is a green technology. You have the economics and performance advantages that we talked about earlier. The density is an advantage in many cases, and thus the economics. Testing and evaluation has to be done on a regular basis to show that you have good control over the process, and then it takes time before the product is accepted. But there are high-end markets in which you can participate that will give you that type of profitability. Now, the easiest markets to get into would obviously be something like wastewater, and that's proof of concept. Once you show and you demonstrate that you can remove various contaminants, then that garners interest in other application areas. That's just one. But there are a number of applications, like I said, that can use powder material, extruded material, but that is what it will take to get your initial, like I said, to get you in the door, as it were. So that pretty much ends my presentation. I know it was rather fast. I apologize if I spoke too quickly. That's just being a verbose individual. That just comes with the territory. So I hope everybody enjoyed the presentation. I'd love to have some chat and answer some questions.
Thank you very much. Thank you, Bill, for your presentation. I think that fitted quite well. And to the audience, if you have any questions, write them into the chat if you want, or alternatively, just unmute yourself and ask directly. So my first question would be, so what do you think is a minimum volume for activated carbon customer to buy? So what would be the minimum volume you have to produce to be considered as a suitable partner?
You would have to be producing millions of pounds a year to be considered a serious supplier. But again, it depends on your target market. The activated carbon manufacturers have long since produced products that were very, very specialized. For instance, the pharmaceutical industry requires a very, very high purity product. And it's made in very, very low quantities because the raw material and the processing required it adds a great deal of expense to it. But these people are also willing to pay perhaps $20 or more a kilo for the product. All right. So it depends on how much you're willing to put into it. But they also might make it from olive pits. They might make it from peat. So there are other raw materials that can be used. But again, it depends on how much processing you want to do versus your end product. Now, typically in commercial activated carbon manufacturing, they have to base load a facility. In other words, you have to run a certain volume through the kilns to be able to justify the existence of the plant, the labor, the energy costs, everything. So they will go for high volume markets, which in the United States would be water, for instance, which is hundreds of millions of pounds a year. So that's where you would base load your plant, and then you can go for the more specialized grades. So I would say that you would have to be in continuous production. That is an absolute minimum. Now, whether it's a few 100,000 pounds, or a few million pounds, it all depends on your target market and where you're trying to, your outlet. But like I said, it has to be consistent. And again, you have to do the economics depending on the raw material, where you are and where your markets are.
Yeah, thank you. So you got some questions in the chat now. So the first one from Vineta Rana. Are you familiar with soil applications of biochar? So biochar prepared at what temperature is considered as best for soil application? Not sure if that's your special subject.
For soil application, I don't know that there is an optimal temperature. Again, it depends on the raw material. And again, the different types of pyrolysis that Pietro referred to can make a tremendous difference. And again, a lot of times in biochar, what I've noticed is that biochar is a co-product. In other words, you might have an energy producer that is producing a biochar as a byproduct. So they really can't affect that much. They can't change the process because it's, I don't like to use the word waste product, but a byproduct. And they might do a flash pyrolysis in which it's exposed to 1,000 degrees, but for 10 seconds, So I don't know that there's an optimal temperature for a soil application, but I would, there are activated carbon manufacturers, one in Florida in particular, that produces a steam activated wood. They don't do a chemical activation, and they produce a 500 iodine number product consistently, and it's used in water treatment. So that would certainly be suitable for soil application.
Pietro, you have a question?
Yeah, I wanted to ask some questions in the chat. First, about the pyrolysis for fertilizer, you have to refer to at least in Europe, to the certification we have. We have certification schemes for biochar, and for the different uses of biochar, they give the specifications. At least an idea of the best parameters. Let's say that for soil application, the problem is the IPA, PAH content, polycyclic aromatic hydrocarbons, let's say so. So you have to find a temperature which does not produce this if you put this in the soil, more or less. And dealing with the question on LCA of activated carbon and biochar, I'm not aware of any study about this. But you have to consider that these are really different applications. I don't know if the use of activated carbon can be coupled to how to say carbon storage use of biochar. So it would be also difficult to make such a study. Let's say so. That's it.
I appreciate it, Pietro, very much. Thank you.
Bill, the same question to you. It was from Charles Heckberg. Do you know data on the LCA of activated carbon versus biochar?
Not that I'm aware of, but that doesn't mean it's not out there.
Yeah, I personally only know one that was done by Thompson at some point in wastewater treatment. And then biochar was in some categories it was beneficial, in others not. But I think I think we're not at the LCA level so far. I think there are a couple of question marks still. How to compare the two products. The next question for you, Bill. What would you think? I think I know what you will answer. What do you think would be the ideal biomass for preparing biochar? And connected to that, what production costs would you think is acceptable at the market?
Okay, give me that question if you wouldn't mind. The first question was
What would you consider an ideal biomass for preparing biochar for activated carbon applications?
That is a really good question, because one of the things about biochar is it is so versatile. There are so many biochars. There are some that will lend themselves better to activation. For instance, if you were to use say for instance walnuts or soybean husk, this is a ready, plentiful raw material that can be easily manipulated. You don't have to worry about moisture content. You don't have to worry as much about homogenization of your raw material. So a large production, like I said, a large hard shell might be something that would be suitable or easier, I will say, lower cost to get into or begin experimenting with. But again, the biochar, there are so many sources of biochar, and depending on how you manipulate them chemically and thermally, you can literally tailor the product to just about anything you want. In fact, there was an earlier question about chromium removal by biochar, and again, because of its capacity for metals, and I'm sure that there are articles out there. I may even have a couple here on my computer, but I would say that it would absolutely, you could make a biochar. I know activated carbon can remove it, so definitely a biochar could. Especially hexavalent chromium allows itself to be removed. It's much more absorbable. So, and the second part of the question, Christian, was
what production cost per biochar ton could be adapted on the market? What would you say?
What price could you get for the product?
Yeah. So basically, how high or low can you go?
Well, again, if you're looking at something like wastewater treatment, you're probably, and again, forgive me, I'm going to give this in US dollars. You're going to be probably at 50 cents a pound, 50 cents a pound to 75 cents a pound. Drinking water may go from 75 to $1. Odor control, you could get as much as $2 a pound. Like I said earlier, with the pharmaceuticals, you might be able to get $10, $20 a pound or more. So it just depends on how, like I said, your end target market is going to determine the cost of it and the demand for it.
Mm-hmm. You already answered one of the other questions now as well, so that's great. Because there are two more. So Vera Bodu was asking, could you share some commercial biochar producers that use continuous processes that you're aware of, and their approximate production capacities?
That I do not know. I know that there are a number of producers of biochar. There are several here in the United States. Biochar Now, Biomass One, mostly located in the western part of the United States, where there's a lot of forestry. There's also probably producers in Minnesota. I'm sorry, I couldn't. There are a number of them that are in continuous production. Now, whether or not they're producing the quantities as like a Norrit or a Calgon, doubtful. None that I'm aware of. But there are large producers in the United States. I would just have to do a market study on it to find out.
What would be a volume of activated carbon like Norrit, like a range? Is it
Norrit would produce 150 million pounds a year in the United States. They had two plants. One produced about 100 million, one produced about 50 at max capacity. And call it 130 million.
Yeah, that's quite a...
Yeah, and Calgon probably is in the same range, 150 to 200 million. But again, primarily their products are coal.
Mm-hmm. Okay. And one question from myself before we answer the last two remaining questions there. So what would you say is the ratio of chemical to physical activated carbon in the market right now?
Oh, by far, straight physical activation is by far, because the chemical activation automatically adds a cost to it. For instance, Norrit actually made a wood-based carbon, utilizing a phosphoric acid to break down the cellular structure. But that production never went beyond 5 million pounds a year, but we could sell every pound we could make. So there is definitely a demand for the higher end product.
Yeah. And the last question, because there are some questions that are more related to biochar production, but we are a bit over time already. From Paul Anderson. So after the application, what is the activated carbon industry doing right now? Are they incinerating the used activated carbon, or what are the disposal routes?
Typically an activated carbon manufacturer, if it's going into a non-critical application, well, no, let me put that in a different way. They reactivate. They will take back the spent carbon, and typically customers will call that in as part of the contract. In other words, you come and change out the carbon, you take our old carbon back, you take ownership of it, you get rid of it. Now, it is possible to landfill carbon, but most people don't want to do that because of the costs associated with, and because obviously we don't want to continue to fill up the landfills. So activated carbon manufacturers will bring back the carbon to their plants and reactivate. Now, they will typically segregate the reactivation, because I don't want to mix something that I used for drinking water. I don't want to mix with something that was used in an industrial application. So that you have hazardous and non-hazardous, and those are separated. But typically the activated carbon is reactivated and then resold into a less critical application. So something that was originally a drinking water application, once it's reactivated, will go into wastewater, something like that. And of course, there's a certain amount of makeup carbon that needs to be added to it as well.
And the last application would be usually incineration, or, for example, if you have heavy metals on them.
No, they would still typically, it would be considered hazardous. You have to have special permitting. They also have vapor, obviously, probably more carbon to capture vapors and the like. But there is a time where you can landfill it, and it needs to be landfilled. But like I said, they try to reactivate whenever possible.
Okay. Okay, great. Thank you very much, Bill. If you have more time, you can. You're very welcome to answer all the remaining questions in the chat. Unfortunately, we are already over time. So thank you very much, Bill. And if anyone wants to watch this presentation again, you will find it in a couple of days on our website. And now I close the other. And we will have our next webinar in 2 weeks. And then talking about a different application of biochar, and that is in the mining industry. So Marshall Mermel will talk about circular mining and mine remediation with biochar, and we will have a presentation about smallholder farmer biochar projects and credits in India. So thank you very much for joining today, and I hope it was useful for you, and I hope to see you again in 2 weeks.